Today's presentation was part of a seminar entitled Low Technology Hydroponic Methods for Growing Potatoes in Hawaii with co-authors University of Hawaii Mililani Agricultural Experiment Station Farm Manager Milton Yamasaki and Agricultural Research Technician Roy Ishizu. The seminar was presented during August 2008 at the International Potato Center in Lima, Peru. To get you into a potato mood, have a look at this marvelous assortment of potatoes which was on display at the International Potato Center. Experiments were conducted at the Mililani Agricultural Experiment Station on the Big Island of Hawaii at an elevation of approximately 850 meters. We want to develop simple and cost-effective container and tank methods for growing potatoes. This study does not involve the field culture of potatoes. We feel that highly sophisticated hydroponic systems are just too challenging for many growers. Conventional container growing methods require too much growing medium, and this is not cost-effective. After all, growing medium costs a lot of money. To develop a simple growing method, let's borrow a method from clever gardeners. First, place a seed potato on top of the soil surface. Then, cover the seed potato with dry grass or straw. The seed potato sprouts and the foliage grows through the dry grass. At the end of the crop, remove the grass and pick up the new potatoes. Okay, so this leads us to grow potatoes in bottom perforated polyethylene bags which are supported by the floor of a tank and immersed in 2.5 centimeters of nutrient solution. Bags were partially filled with 5.6 liters of a peat perlite growing medium and filled with hillings of dry grass as the season progressed. The 2008 Hawaii cost of the 5.6 liters of growing medium in the bag was $1.12, which is a 70% savings as compared to a filled bag, which costs $3.78. Here are the partially filled bags resting in a 60 centimeter wide polyethylene lined tank. The bag spacing was 60 centimeters by 30 centimeters. The bags were unrolled as needed when filled with hillings of dry grass. The nutrient solution depth in the tank was maintained by a float valve. The first experiment with this growing method was conducted to determine the effect of potato seed piece size on yield. 3 seed piece sizes were compared: 4 grams, 20 grams, and 52 grams. The 52 gram size seed pieces produced greater yields than the 4 or 20 gram seed pieces. A saleable yield of 7.5 kilograms per square meter of tank was obtained from the 52 gram size seed pieces. Could we get a higher yield with a larger seed size piece? Well, we don't know, and that would take another experiment. You're probably asking, is that a good yield or not? Well, for reference, the 2008 field production of potatoes in Idaho, which is the state with the most potato production, was 4.25 kilograms per square meter. Before we get too excited about this high yield, we have to realize that potatoes growing in tanks in a greenhouse would need about 1/3 of the area for aisleways. Then the 7.5 kilograms per square meter of tank area becomes 5 kilograms per square meter of greenhouse area, which is about 1.02 pounds per square foot. So the growing method still looks pretty good. How many seed potatoes should be planted in each bag? We found there was no difference in saleable yield from planting either 2 or 6 seed pieces per bag. Since the bags were at a 60 by 30 centimeter spacing, this means that there will be 1 seed piece per 30 by 30 centimeters, or about 1 per square foot. Even though the sub-irrigated bag with dry grass growing method uses 70% less growing medium, the cost of the growing medium is still $1.01 per kilogram of potatoes. This is just too high. This was based on Hawaii's growing medium cost in 2008. The next trial was conducted to determine the effect of 4 cultivars on yield. The cultivars were All Blue, Catalina, Huckleberry, and Yukon Gold. The growing method was to use sub-irrigated 18.9 liter bags with 5.7 liters of growing medium plus dry grass. Total saleable yields of Catalina and Yukon Gold were in the neighborhood of 6 kilograms per square meter. and were statistically similar to all blue, but greater than huckleberry. Yukon Gold had the highest proportion of extra large sized potatoes. The growing medium cost averaged over all the cultivars was $1.19 per kilogram of potatoes. Again, this is just too high. Another experiment was conducted to compare 3 growing methods where only 2 liters of growing medium was used per seed piece. The treatments were an 11.4 liter polyethylene bag, an 18.9 liter polyethylene bag, which were sub-irrigated and hilled with dry grass, and nursery trays elevated 5 centimeters with 3 seed tubers which were hilled with dry grass. For the last treatment, an upright nursery tray sits on an upside-down tray. There were 3 piles of a seed piece covered with 2 liters of growing medium, and the whole tray was hilled with dry grass. Yields from the tray treatment were the highest, with slightly over 5 kilograms per square meter of tank. We were disappointed with these rather low yields. Although only 2 liters of growing medium were used per plant, the cost still was 86 cents per kilogram of potatoes. Let's look at more ways to reduce the growing medium cost. Yes, let's try some hydroponic methods that use less growing medium. In an attempt to reduce the need for growing medium, the following 4 treatments were compared. First, the sub-irrigated bag with 2 liters of growing medium per plant, followed by hillings of dry grass. Next, a 10 centimeter suspended pot method. Then, a wrap in newspaper method followed by hillings of dry grass. And finally, a no growing medium method where there was only hilling with dry grass. A suspended pot method has been used successfully with lettuce, so maybe it'll work for potatoes. In this method, initially, a small net pot is partially immersed in nutrient solution, thus automatically watering the plants. As the roots grow, the nutrient solution level drops, and this zone is now occupied by moist air. The expanding root system gathers water and nutrients. For potatoes, we will use a 10 centimeter pot with 1 seed potato. Here are potatoes growing by the suspended 4-inch pot method. The sides of the pots are slit, and the pots are filled with peat perlite. This pot is really bulging with the new potatoes. The roots are gathering water and nutrients from about a 5 centimeter level of nutrient solution in the tank. The pots are suspended from an expanded polystyrene tank cover. Dry grass was hilled over the top of the pots. This pot is ready to harvest. It's really packed with the cultivar all blue potatoes. Would you believe all these potatoes were growing in that pot? And there was a 70% savings of growing medium as compared to the 18.9 liter bag method. Growing medium was completely avoided by wrapping the seed potato in moist newspaper. This method will take some time and practice. The seed potato is placed on a nursery tray. Capillary action wets the newspaper. The potatoes emerged through openings in this plastic cover, and they were hilled with dry grass. Avoid using glossy newspaper, just use regular newspaper. If the potatoes were wrapped with the comic section newspaper, would the potatoes taste funny? Sorry, I couldn't resist that. Here are potatoes growing by the wrap in newspaper method. At harvest time, there's just new potatoes and old beat-up newspaper. There was a no growing medium treatment. Seed potatoes rested on a nursery tray. The foliage emerged through openings in the polyethylene cover, and the plants were hilled with dry grass. As you can see, the performance was underwhelming. In this sub-irrigated bag treatment, there are 2 seed potatoes and 4 liters of growing medium per bag. Bags are unrolled when hillings of dry grass are added. The spacings of the bags are 60 centimeters by 30 centimeters, which means there is a 30 centimeter by 30 centimeter spacing for each plant, which is the same as the other 3 treatments. The potatoes in the bag treatment grew well. There's a lot of new seed potatoes in the bag treatment, but remember, there were 2 seed potatoes per bag, and the spacing was 60 centimeters by 30 centimeters as compared to the 30 centimeter by 30 centimeter in the other treatments. Here is a visual comparison of 4 cultivars growing by the wrap in newspaper method and the 18.9 liter bag method. Yukon Gold produced the highest yield and Huckleberry produced the lowest yields. Looking at the total saleable yield of Yukon Gold potatoes, we notice that the wrap and newspaper treatment had the highest yield and the no-growing treatment had way the lowest yield. The yields from the 18.9 liter bag and the 10 centimeter pot were statistically similar to the wrap and newspaper method. The potato yield for the Yukon Gold wrap and newspaper method was 7.2 kilograms per square meter for the tank area. Since 1/3 of a greenhouse area would likely be aisle space, this yield would adjust downward to 4.8 kilograms per square meter for the whole greenhouse area. So here, a hydroponic growing method that uses no growing medium actually beat the 2008 Idaho average field potato yield. Wow! The growing medium cost for the 18.9 liter bag in this experiment was 74 cents per kilogram of potatoes, and that's the best so far in this series of experiments. However, the cost was reduced to only 24 cents per kilogram for the 10 centimeter suspended pot method, and there was zero growing medium cost for the wrap and newspaper and no growing medium methods. If we could get several more uses of the growing medium from the bag and pot treatments, they would become more affordable growing methods. The average water consumption from experiments 2, 3, and 4 was 51 liters per kilogram of potatoes, and this is equivalent to 6.1 gallons per pound of potatoes. The fertilizer used in these experiments was a 1-to-1 ratio of 2 fertilizer stock solutions. Stock solution 1 was HydroGarden's ChemGrow 41838 at 120 grams per liter plus 72 grams per liter of magnesium sulfate, and stock solution 2 was 120 grams per liter of solution-grade calcium nitrate. Depth of the nutrient solution ranged from 2.5 to 5 centimeters in the various experiments. The EC, or electrical conductivity, of the growing solution ranged from 1.5 to 2.0 ms. There is a link to an article entitled Sub-irrigation Methods for Growing Potatoes in Containers under a Rainshelter with co-authors Milton Yamasaki and Roy Ishizu. This publication provides additional details for the experiments in this video. So what should I do with my free time after giving my seminar at the International Potato Center in Lima, Peru? Well, go to a grocery store and look at potatoes, of course. Well, I also did visit the amazing Machu Picchu. For now, it's adios.